Hi, last time we did this. We expanded brackets, and if you expand the brackets in here, you would multiply x by 3x to get 3x squared, and then the negative 6 by 3x to get negative 18x. And that was called expanding brackets. Now in this lesson, we're going to do it the other way around. So we're going to start with this, and we want to end up with that. And that process is called factorization. So we're factorizing. And what factorizing means, it's expressing an expression as a product of its factors. We can factorize numbers too if we wanted. If we, for example, wanted to factorize number 6, so express that as a product of its factors, we could express it as 2 times 3. That's easy. But now we're doing the same thing for expressions. Let's have a look at some examples. Now, example A, example 1 says that fully factorize. The fully in there means that factorize as long as possible. Now, you have 2 terms, and you would first have to think what is the greatest common divisor of the coefficients in here, so 7 and 14. So what's the biggest number that divides both of them? Well, it's 7, because 7 is 7 times 1, and 14 is 7 times 2. Then what you will write in your notebook is the 7 and then open brackets after that. Then you will have to think that what times 7 would make the first term on the left-hand side. So what number would you have to multiply 7 by to get 7? Well, it's 1, because 1 times 7 is 7. So you'll put 1 as in the first place in the brackets. Then for the second place in the brackets, you'd think, what do you need to multiply 7 by in order to get 14x? Well, 2 times 7 is 14, and then you would need the x in there, so 2x times 7 is 14x. So then write 2x. And that's it. Now we've expressed this as a product. And you can check your factorizations by opening the brackets. So 7 times 1 makes 7, and 7 times 2x makes 14x. And this matches with the expression that we started with, so you've done everything right. B. 10x to the power of 4 plus 2x cubed. Now again, find the greatest common divisor for the coefficients of the terms, so 10 and 2. Well, the biggest number that divides both of these is 2. So 2 is going to be in our common factor. Then have a look at the variables, and the common factor will have the lower power of the variable. Now in here we have x to the power of 4, and in here we have x to the power of 3, so the common factor will have x to the power of 3. So the whole common factor is 2x cubed. Then in your notebook, write down the common factor 2x cubed and then open brackets, and then think, for the first place, what do you need to multiply the common factor with in order to get the first term on the left-hand side? So what times 2 is 10? Well, it's 5. And what times x cubed is x to the power of 4? Well, it's x. So 5x in the first place. Then the second place, what times 2x cubed is 2x cubed? Well, it's 1. 1 times 2x cubed is 2x cubed. And now we factorize that. We can't factorize any further. And if you want, you can check that factorization by opening the brackets and checking whether the result matches with the expression that we started with. Now, last time we used this formula from the left-hand side to the right-hand side. And that was called opening brackets. But today we'll use this formula from the right-hand side to the left-hand side, and that's called factorization. Now, example, fully factorize again. 25 minus 16t squared. Now, let's first check. We have two terms in here, and we have a minus between the two terms, so it looks awfully lot like this. Now, to know whether we can use the formula, we'll have to check whether this 25 is a square of something and whether 16t squared is a t of something. Now, 25 is what squared? Well, it's 5 squared. 16t squared is what squared? Well, it's 4t squared. And after you figure out that, when you know that a is 5 in here and b is 4t, then you can work your way from the right-hand side to the left-hand side. So you can write it in the form 5 plus 4t times 5 minus 4t. And that's factorized now. B. In here, we have two terms and a minus sign between them. Notice if you have a plus in here, you could not use this formula, but we have a minus sign, so we're okay. Then we'd have to think whether this is a square of something. Well, now to start with, 18 isn't a square of any integer. And if we have a look at this, 8 isn't a square of any integer either. So we can't use this straight away. But we will notice that we can factorize this expression first, because 18 and 8, they do have a common divisor, and the biggest common divisor for them is 2. Then both of the terms have d, and we'll choose the lower power of d, and it's d to the power of 1, into our common factor. So our common factor is 2d. Then open the brackets again and think what times 2d makes 18d cubed? Well, 9 times 2 makes 18, and d squared times d makes d cubed. So we'll have 9d squared on the first place. Then what times 2d makes negative 8d? Well, negative 4 times 2 is negative 8. And then you have the d from there, so it matches. And now, after this factorization, if you look at the two terms inside the brackets, you'll notice that you can apply this for them. Because 4 is 2 squared and 9d squared is, in brackets, 3d squared. So then, this is our a and that's our b, so you can write down this as 3d plus 2 times 3d minus 2. And then we're done. Now, this example is mainly for the students that are going to choose analysis SL or any AHL. But these questions will be a part of the exam, so it still might be worth having a look at these for the application students too. Now, in example A, we have two kind of terms. We have the first in here and then the second. Now we have to think, what did these two have in common? Well, both of them, they have 2x plus 1. And that 2x plus 1 is going to be our common factor. Then place it on the place of the common factor and open brackets. Then on the first place, you'd think, what times 2x plus 1 makes 8 times 2x plus 1? Well, the 2x plus 1 is multiplied by 8 in here, so you'll have to put 8 on the first place. Then the second place, what times 2x plus 1 gives that? Well, 2x plus 1 has been multiplied by negative x plus 5. So you would have to put that on the second place. Then you can open the brackets in here. So the minus in front of the brackets is the same thing as multiplying both of the terms inside the brackets by minus 1. So minus 1 times x is minus x, and minus 1 times 5 is negative 5. And then 8 minus 5 makes 3, so you'd have 3 minus x inside the brackets. And now we factorized this. We've expressed it as a product of two factors. B. This is quite the same as the A, but instead of us having two clear terms to begin with, we don't have them yet, and we would have to express these with factors that have something of the same. And now, in here, in the first term, you have x plus 4. How do we express this with the help of x plus 4? Well, what do you have to multiply x plus 4 by to get negative x times minus 4? You'd have to reverse the signs inside of the terms inside the brackets. And what does that? Minus in front of the brackets does that. So minus times x gives minus x, and minus times plus 4 gives minus 4. And now we have two terms, this and that, and they both have x plus 4. So x plus 4 is our common factor. Then again, inside the brackets, think what times x plus 4 makes the first term in here? Well, x plus 4 has been multiplied by x, so we have to put x in here. Then what times x plus 4 gives that? Well, x plus 4 has been multiplied by negative 1, so we'll have to put negative 1 in here. And then we're ready again. C, and that's the very last example for today. Now, we'll use the same line of thinking for these. So we'll try to express this and that so that they would have an expression of the same form as their factors. So what we'll have to do is first factorize that and then factorize that and hope that they will have something in common. Let's start by factorizing that. The coefficients don't have any common factors, 1 and 3, but both of the terms have a variable, and the lower power of the variable will be our common factor. We have x squared in there and x over here, so our common factor will be x. Then, what times x makes x squared? Well, it's x, because x times x is x squared. What times x is plus 3x? It's plus 3. Then the same thing for these. Negative 2 and negative 6 can both be divided by negative 2. So that's our common factor. And then what times negative 2 is negative 2x? Well, it's x. And what times negative 2 is negative 6? It's positive 3. And now you can see that both the terms have x plus 3 in them, so we can further factorize this for x plus 3. And the first term has been multiplied by x, and the second in the second term, x plus 3 has been multiplied by negative 2. And now we have fully factorized that.